Welcome. Today we're diving into continuous improvement, focusing on SIP performance. We'll explore how small, steady changes can lead to big results over time. I'm Dr. S.K. Singh, and together we'll uncover strategies to keep pushing performance higher, step by step. Let's get started. Let's start with an introduction to sterilization in place, or SIP. It's a vital process that keeps pharmaceutical manufacturing systems sterile and safe. While initial validation shows that the process works, keeping it effective over time means more than just a one-off check. We need continuous monitoring, regular reviews, improvements based on risk, and decisions backed by solid data. The key idea here is that validation isn't a single event. It's a continuous journey of verification and improvement. Let's talk about the regulatory framework guiding our work. Key organizations include the European Commission, the U.S. Food and Drug Administration, the World Health Organization, and the International Council for Harmonization. Each sets important standards we follow. A core expectation is clear. Our sterilization process systems need regular review and ongoing improvement. This keeps them validated and ensures we maintain sterility assurance over time. It's about staying vigilant, not just compliant. Continuous improvement isn't just a nice-to-have, it's essential. Over time, equipment ages, sensors drift, steam quality varies, and processes change. Maintenance and higher production demands add more complexity. If we don't keep up, the risks grow, sterility assurance can fail, validations can slip, regulators may raise concerns, and worst of all, contamination can happen. Our goal is clear. We need to maintain sterilization effectiveness throughout the entire equipment lifecycle, no exceptions. Let's walk through the SIP lifecycle management approach. It starts with system design, laying the groundwork for everything that follows. Then, qualification and validation ensure the system works as intended. After that, routine monitoring keeps a close eye on performance day to day. Trend analysis helps us spot patterns over time, while deviation investigation digs into any unexpected issues. CAPA implementation, that's corrective and preventive actions, addresses problems and prevents recurrence. All of this drives continuous improvement, keeping the process robust and compliant with regulations. When it comes to good manufacturing practices, we expect key performance indicators, or KPIs, to be reviewed regularly and tracked over time. This helps us spot trends and catch issues early. Some critical KPIs include the SIP success rate, which tells us about cycle reliability, and temperature uniformity, showing how well heat is distributed. We also monitor sterilization, hold compliance for consistent processes, biological indicator results to assure sterility, alarm frequency for stability, deviation rates for operational performance, and equipment downtime as a measure of reliability. These metrics keep everything on track. When we see any sign of process drift, it's a signal to pause and investigate before things go wrong. Here, we're looking at key parameters that need constant monitoring to keep the process on track. Temperature, pressure, exposure time, all must stay within tight limits. Steam quality and air removal efficiency also matter. These validated sterilization conditions ensure safety and consistency. By keeping a close eye on these factors, we catch issues early and maintain control. Let's talk about periodic requalification programs. They're all about making sure our SIP systems keep working exactly as they should, within their validated conditions. To do this, we run a series of checks: temperature mapping, steam penetration studies, biological indicator tests, instrument calibration reviews, and alarm challenge testing. These activities help us catch any drift or issues early. Typically, these requalifications happen annually, or more often if the risk calls for it. It's a vital part of maintaining system reliability over time. Let's talk about deviation management and CAPA, that's corrective and preventive action. Every deviation in a process isn't just a problem to fix, it's a chance to get better. Take this example, a temperature excursion during sterilization. The root cause, a malfunctioning steam control valve. The corrective action was to replace that valve, but we didn't stop there. We added a preventive step, an enhanced maintenance schedule. The result, fewer temperature-related issues down the line. Continuous improvement in action. Let's talk about data integrity and digital monitoring in modern SIP systems. These systems use tools like SCADA and PLC-based monitoring to keep everything running smoothly. Electronic batch records and automated audit trails help us track every step, while real-time alarms catch issues before they escalate. This isn't just about technology. It's about meeting strict standards set by regulators like the FDA and the European Commission. The payoff: better traceability and the ability to control processes proactively, not just reactively. Let's talk about risk-based continuous improvement using the principles from ICHQ9. We start by evaluating risks, things like equipment failure, sterility loss, human error, and utility interruptions. For example, a risk assessment might reveal condensate building up in a transfer line. The improvement? Adding an extra condensate drain point. This simple change leads to better steam penetration and more consistent sterilization. It's a clear case of identifying risk, taking action, and improving quality. Let's explore the advanced technologies that are pushing steam injection processes to the next level. We're talking about artificial intelligence, predictive analytics, the industrial Internet of Things, digital twins, smart sensors, and continuous process verification. Together, these innovations help us move from reacting to problems to anticipating them. For example, AI can spot subtle declines in steam quality before they become an issue. That means we can intervene early, keeping operations smooth and efficient. It's all about being proactive, not just reactive. Here, what we found after making some targeted improvements to the bioreactor SIP system. Before, we had 10 deviations a year, now just 2. Cycle failures dropped from 6 to 0. The risk to sterility went from moderate to very low. Equipment availability climbed from 92 to 98%. We tackled frequent alarms, temperature swings, and long cycles by recalibrating sensors, optimizing steam traps, automating monitoring, and stepping up preventive maintenance. These changes made a real difference. As we wrap up, continuous improvement is really a commitment to staying vigilant. It means managing the entire life cycle, keeping a close eye on performance, and tracking key indicators over time. We need effective corrective actions, risk-based assessments, and regular requalification to stay on track. Data integrity and embracing new technologies are equally important. Regulators expect manufacturers to prove their systems stay controlled and reliable throughout their entire operational life. That's the foundation of lasting quality and compliance. Thanks for joining me today. If you need any more support or have questions, please don't hesitate to reach out. I appreciate your time and attention, and I look forward to continuing the conversation. Thank you. This video was created with SlideSpeak. Visit SlideSpeak to turn your presentations into engaging AI-narrated videos.